Bienvenidos, Ushamadid, and welcome UMGC learners from the CMIT-455 Section 6380 course for the spring 2021 semester. This is the Cisco Networking Academy CCNP ENCOR version 8 course curriculum, and in this packet tracer tutorial and solution set, we're going to be taking a second look now at configuring extended IPv4 ACLs. And so this is scenario number 2, and again, I really like this activity as it walks you through some of the tasks that you're going to have to configure here. So the objective, again, configure a named extended ACL and then apply and verify that extended named ACL. And so here are the instructions. Let's go ahead and get started. We're going to block HTTP and HTTP access from PC1 to server 1 and server 2. We're going to block FTP from PC2 to server 1 and server 2. And we're going to block ICMP from PC3 to server 1 and server 2. So we're going to have a pretty busy access control list, extended ACL, with multiple access control entries, or ACEs. And those are each of those permit and deny lines that we're going to be dropping in to this ACL. So if we were to scoot up here, you can see deny PC1 access to HTTP and HTTPS services on server 1 and server 2. So before we do that, let's make sure that this actually works before we block it. And it's always a good idea, and we'll give ourselves a little bit more room with which to work. It's always a good idea to test to see, does our connectivity out to server 1 or server 2, and for PC1 we're going to check both of these guys. So let's check 64.101.255.254. And again, it comes up right away, meaning that we've got connectivity. And then we'll change that second octet from 101 to 103. And I'll click on go, and let's kind of poke around here. And you can see we're still on 103. So it did change. So I do have HTTP access from PC1. Sorry about that. Went past where we were going to go. So what is the command to begin the configuration of an extended ACL where we have a name for the ACL? Well, let's remember, if I was to pull up router 1 here, and that's where all of our configuration work is going to be done in terms of the ACLs. And let's say show access list. Are there any ACLs on here right now? There are not. So we're going to go from user exec into privilege exec with a config T or conf T configure terminal command. And if I was to say access list without the IP preceding it and do a question mark, you can see here that it only shows me options for numbered ACLs. Oops, I highlighted too much there. For numbered ACLs. If we were to step out and let's see if we can get connected here to a router, this might not work. Yeah, it's not going to work. Power outage here recently, so those are still off. So the access list is only going to show us the numbered ACL options we have. But if we were to come back and precede this with IP access list, now we see we get some different options. So here it's going to be asking me, is it going to be standard or extended? And as soon as I put extended in here, you can see that we get the numbers, and that would be used if I was trying to go in and edit or make modifications to an extended numbered ACL. And that's where I would put in, 101 to get into that ACL to be able to make changes, edits, modifications. However, we're creating a named ACL. And so it says, what is the command to begin the configuration of an extended access list with the name ACL? And again, it's just simply IP access list extended and then the name of that ACL. So we're going to begin the ACL configuration with a statement that denies access from our source PC1 to server 1. And this is only for HTTP port 80. And again, we'll refer to the addressing table. I'm sure we're going to have to roll back there to see what we're looking at some point. However, here you can see that they actually provide us with the syntax that's required. So let's talk about this. So we're saying deny the TCP protocol from the host. Deny TCP host. I had to look back up there. 172.31.1.101 going to the host. Again, these would be /32 subnet masks, right? And those would convert into wildcard masks of quad 0. So what I could say, instead of using host, and I'll change it because we're going to want the points, obviously, but as a reminder, what I could say is quad zeros afterward. That is the equivalent of that all 255's /32 host route syntax. However, right, with Cisco, we've got this really convenient keyword that we can use to avoid that quad 0 entry, equal to port 80. So, and we're gonna place this on the interface closest to the source. So it's going to go on this inside interface here on router 1. And when traffic is coming inbound, in other words, ingress traffic, that's how we're going to be applying this ACL. So as traffic is coming into this interface, router 1 is going to examine that traffic, and it's going to say if it's coming from that host IP address and it's TCP and it's going to this host address, that exact host address, and the destination port is port 80, well, then I'm blocking it, right? And you can see how much more granular we can get when we're using the extended ACLs. We've got the protocol in there. We've got the source IP in there. We've got the destination IP in there. And we've got the protocol or the destination port number that's being used. So we got very, very granular there so that we are only blocking HTTP traffic from PC 1 going to server 1. And we hit enter. And they're probably not going to give us points here until we get some more stuff entered in. All right, so next we're going to enter the configuration statement that denies access from PC 1 to server 1 for HTTPS. Now, if you look at that line, you might be saying to yourself, well, if I just hit the up arrow and change the port to 443, that's the command. And you're absolutely right. That is the command for this access control entry, is deny TCP host, the IP address of PC 1, host, the IP address of server 1, and then the destination port number, right? Remember, these are not stateful access control lists, right? These ACLs, access control lists, are not stateful. It is not keeping track of the conversation and the source and destination port numbers. It is literally inspecting every single packet that comes into this interface once we apply this ACL, and it's checking to see, is this the source IP? Is it TCP as the protocol? And is that the destination IP and destination port number? If it is, then we're going to deny it. So we'll go ahead and hit enter there. So that was step C. So now step D is going to block TCP going to port 80, but server 2 for PC 1. So again, we hit the up arrow twice, and the only thing I need to change is the second octet in the server IP. Because PC 1 is still the server, we're still denying TCP from host 172.31.1.101. Now it's just going to another host, another server, server 2. And the port is still 80. And so if you thought that we could hit enter, hit up, and then simply enter in 443 to knock out the next step, you're absolutely right. So that takes care of D and E. So now let's go ahead and scroll up a little bit more here. So now we're going to be denying PC2 FTP access to server 1 and server 2. Now, we could also leverage these previously run commands, because let's take a look. If the IP is 172, and we're still talking about TCP as the protocol, because FTP, like HTTP and HTTPS, leverages TCP at layer 4. We have 172.31.1 102 for server 2. Going to, and this is going to, I'm sorry, not server 2, PC2, and then host 64.103, and we're going to change that. So we'll take care of the server 1 entry first, and FTP port number 21. And so I'm blocking it from server 1, and I'm also blocking it, blocking PC2's access getting to server 2. So we'll change that to 103. And that's it. So we've got a pretty nice ACL being developed here. So that takes care of step 2A and B. Now we're going to be taking a look at step 3. We're going to deny PC3 the ability to ping server 1 and server 2. And so I tested HTTP. And again, we haven't applied the ACL. And so this is kind of one of those fortuitous things as I was thinking about the next thing I'm getting ready to say here. Well, you might be asking, well, you didn't test to see, can I FTP to server 1 and server 2 off of PC2 before you created the ACL? Well, remember, creating the access control list and creating the access control entries, as I've done right here, doesn't change anything. I have to apply the ACL because watch, if I come here and take a look at the copyrights, this is all still working. Small page, back, let's take a look at the image, file not found, copyright. So HTTP, and if I was to change it to HTTPS, would still be working. Let's pull up PC2 and let's see what happens when I try to FTP over to 255.254. We get the username prompt, right? And I'll punch out of there and let's say, can I FTP over to server 2? Whoops, sorry about that. It's 103, FTP over to 103, and it works, right? So same thing, PC3. So before we apply the ACL, right? And again, you could have done this after the ACL was fully created, but I'm just doing it now because it came up. So ping 64.101.255.254. So can PC3 ping server 1? What about server 2? Absolutely. All right, so let's go ahead and continue to drive on here. We'll jump back onto the router. We've got all of these access control entries all set up, ready to go. Now we're going to be denying ICMP. So yeah, I could hit the up arrow, but then to change TCP to ICMP, maybe. But let's go ahead and let's start fresh here. So we're going to say deny ICMP host. So we're denying the ICMP protocol from host 172.31.1.103, again, PC3, going to server 1, 64.101.255.254. Now, you'll notice we don't have any port numbers at the end. So what's happening here is we are denying any kind of ICMP. That includes echo replies as well as echo requests. Because remember, the ACL is being placed on this interface and it's inspecting traffic in the inbound direction. But what if the server out here on the internet, and let's say there's a NAT set up, and we try to ping from the internet? Well, that ping is going to come through because we're not blocking ICMP outbound on that interface. And so the ping would come through, it would make it to PC3, and then on the return from PC3, when the traffic is coming in the inbound direction, that is when this access control entry would be evaluated and that ICMP echo reply would be blocked. And that is what we want. We don't want someone from outside on the internet to be able to ping into our network. And again, we've got NAT considerations, obviously, that we'd have to take into account here if we were doing RFC 1918s back here. So something to think about. All right, so let's go ahead and pull that last drawing out. Let's come down here, and there we go. And then we're going to deny ICMP to server number 2. So all we need to change, right? It's the same host, PC3, and it's just changing the server, but we're still blocking ICMP. Now, this is the critical part. This is the number one thing that learners overlook. All of these statements that we've created to this point in the activity are deny statements, meaning that we still have at the end of this ACL an implicit deny all. So, or deny any, however you want to look at it. So if I was to apply this ACL right now, we would definitely be blocking HTTP and HTTPS from PC1 to server 1 and 2. We would definitely be blocking FTP from PC2 to server 1 and server 2, as well as ICMP from PC3 to server 1 and server 2. In addition to that, we would be blocking all other traffic. So in other words, we'd be blocking everything. And that's not what we want, because what we want is for PC2 to be able to pull web pages up, as well as PC3. We want PCs 1 and 3 to be able to FTP to server 1 and 2. And we want PCs 1 and 2 to be able to ping server 1 and server 2. In other words, we want to permit all other traffic. And that right there is the statement that we put at the end of the access control list to say we're going to deny all of these things initially that we've indicated here, but we're going to allow everything else. And that's that permit IP any to allow everything else to come through. So you can see that as soon as we drop the permit IP any in there, we jumped up to 80%, which is pretty nice. Because I'm assuming that the only thing we're going to have left now is to get the ACL onto the correct interface in the correct direction. And that's going to give us those remaining 20 points. So let's take a look at our ACL. Let's say show access list, right? And you can see there it is. We've got our access control entry sequence numbers, 10, 20, 30. That's where we start by default is at 10. We go up in increments of 10. And again, this final permit IP any is at sequence number 90. And you can see here that we put in 80, it changed it to www. We put in 21, it changed it to FTP. So it also wants us to take a look at the show running config and then take a look at the ACL. So let's go ahead and do that. Show run include access, begin access list. And so we take a look at our ACL. Everything looks pretty good right there, right? So our configuration is good. Now remember, none of these things that I'm saying I'm going to block are being blocked right now. Nothing is being done with this ACL. And even after we apply the ACL, or I should say, it's not until we apply the ACL that we're going to see that things are actually going to start happening. So apply and verify the ACL. The traffic to be filtered is coming from that network. We're going to put it in the appropriate ACL placement. Again, depends on the relationship of the traffic with respect to router 1. And in general, extended ACL should be placed as close to the source. So I think that statement should be first, right? Cisco best practice, get your ACL as close to the source as possible and place it appropriately based on the relationship of the traffic with the router that we're making this placement on, right? So and this is pretty simple, right? We've got a single router here. And so the choice is, do I place it on the outside interface or the inside interface? Well, we've kind of figured out that it would be on the inside interface in the inbound direction, because that is closest to the 3 sources that are in question. So let's get into global config. Let's get into do show IP interface brief, and we're looking for that 172, which is going to be gig 00. Access group, right? IP access group is how we apply it. And then we're going to say ACL, and it's going to be in the inbound direction. Now, we've got this place. I'm just making sure here that it's got this. Oh, excuse me. So it actually has a statement that says an untested ACL should never be applied to an active interface. Very good point. It's not a good practice because, again, if I apply this and, there's mistakes in this ACL, it could be catastrophic. So I hit enter, and you can see we've gone to 100%, but now we need to address these questions here that we have at the end. On which interface should the ACL be applied, and in which direction? Well, we talked about that, as close to the source and in the inbound direction, because the ACEs, the access control entries that we have created, are configured so that they're looking at the source as being PC 1, 2, and 3, and the destination as being server 1 and server 2. So it's on that interface when traffic shows up from these PC sources. That's how we crafted this ACL. So to be in the inbound direction, and we saw that because we got the points. So enter the configuration commands to apply the ACL, IP access group, ACL in, and then let's test access, right? And we're going to end up seeing some hit counts over here. So what did we try to block? Well, now let me click on a small page here, or let's click go, and we'll see it looks like it might be cached here. So let me go ahead and type this in. We'll say 64.101. Or we'll do 103.255.254, and I hit enter, and now we see the request is timing out. You can see the green triangles. Every time I click go, they're freaking out because the traffic's getting to the router, but the green triangle on the other side of the router is not doing anything because the traffic is never getting to this outside interface because the ACL here is blocking all of that HTTP traffic. And again, I'm doing this so that we can generate some messages in the log, and then let me click go a few times here, right? And so we're going to see some matches, right, showing me that, hey, the ACL is working. In fact, that's the first thing we tested. So let's go ahead and say, let me go ahead and say write mem, save the config here, and I'll say show access list. And you can also say show IP access list, but it's not really required, right? In this case, and you could take a look, I generated quite a bit of traffic, HTTP traffic anyway, so that we'd have something to look at if we wanted to test HTTPS. It would be as simple as doing this. Click go a whole bunch of times, and you can see requests are timing out. So now let's rerun our command, and now we've got some matches here. So now let's come to server 2. So what were we blocking with server 2? Well, we were blocking FTP. So let's see, can I FTP to server, I'm sorry, on PC2, we were blocking FTP to server 2. So as you can see, we're not getting the login prompt anymore. Let's check and see, what about server 1? Yeah, no longer working like we thought. But let's come to PC1 and let's see, let's make sure, did I break FTP to server 1? And I didn't, so it still works, right? So that ACL that we had in there is looking pretty good right now. So let's take a look at server 2. So that still works. Let me Control C. Can I ping those servers? Because PC1, 64.101, 255, 254 should be able to ping that server. And I hit enter, and there we go. It's working like a champ, right? All right, so the pings were working there. And because again, FTP is what we're blocking from PC2. So let's go ahead now. We'll come over to PC3, and PC3 should no longer be able to ping 101.255.254. And there we go, destination host unreachable. And what's important here is this little message right here. Who's the message from? Who is 172.31.1.126? And why are they telling me destination host unreachable? Well, if we get on the router and I say show IP interface brief, it's our default gateway. So it's the default gateway that has the ACL applied on that interface that's telling me, hey, the destination's unreachable. You can't get there, because I'm blocking that traffic from getting there. And the easy way to see that is to pull PC3 up, take a look at the IP config. There's my default gateway, right? And that's exactly what's going on here. Let's generate again. Let's take a look one more time here. Let's do 103 and confirm. And we've got 100%, but it always helps to take a look and see, does this work? So again, not working, that's great. So we disconnected here. Let's make sure PC2 can ping 101.255.254. And there we go. So we're pretty confident right now that everything's working. The final thing we want to look at, which is now going to give us some rich data to look at is to say, show access list, and take a look here. And it even shows the traffic, right, that we are matching, that we are permitting. But this is what we're interested in here, is all these things that we're denying. And again, I just didn't do HTTPS, but again, not a big deal. All right. A great activity, nice soft landing into extended ACLs scenario number 2. And that is going to do it for this packet tracer tutorial and activity on packet tracer 26.2.2 IPv4 ACL scenario 2. All right, guys, thanks so much for watching. Have a great weekend, and I hope to see you in the next video.